section 1.3 is a section in which we're going to just kind of get familiar with some very basic standard functions which are basically used as parent function to create new functions. Okay, and the simplest one is the so-called constant function. And a constant function is a function written as f of x equal to c, which means that no matter what your x value is, your y value is always the same value of c, whatever c is. For example, here f of x equal to 2.5. That means no matter what you choose for x, you always get 2.5. So, for example, for this one, f of 1 is 2.5. F of 100 is 2.5, and so forth. Doesn't matter what you choose for x, you always get 2.5. For this one, we change it to g instead of f. We call this one g. Okay. So we will come. Let's say g of 0 is negative 3.75. G of 7 is equal to negative 3.75. G of anything, whatever, star, is negative 3.75, and so forth. Okay, so that means whatever input is, doesn't matter, you always get the same output. So basically, then what if you want to graph such function like f of x equal to c, the graph would be a horizontal function at whatever number c is. Like if c is 3, then this is going to be 2. If it's negative 2, will be down below. Okay. Like if you want to graph that function f of x equal to 2.5, here is x, here is y, and then at 1, 2, 3, this is 2.5. You have a horizontal line f of x. And if you want to do the other one, f of x equal to negative 3.75, then you say 1, 2, 3, 4, 3.75 is right there. Then you get negative 3.75, you get negative 3.75. So we call it G. I call it G. Okay. You can do this on your graphing calculator actually. You see, if you go to your graphing calculator, you say f of x equal to 2.5. See, you get a horizontal line at 2.5. Now if you go to the second function and say negative 3.75, then you get that line right there. Okay, so pretty simple. The next simple functions are linear functions. Linear function, the reason for the name is the fact that the graph of the linear function is a straight line, is a line, straight line. Straight line, like this green line, or this red line, or this green line. Maybe I'll make it black here, so it'll be different colors. These are all linear functions. The graph are a straight line. And the equation is like ax plus b. A is the slope, b is the y-intercept. So slope tells you how sharp the graph rises or falls. If a is positive, the slope is positive, like this green graph and red graph, the graph would be rising, increasing. And the slope of this green graph is bigger than the red one because it's going up sharp. If a is slope and is negative, then it goes down. And wherever your intersect y-axis, it would be your the b value. Okay. And just for the sake of discussion, we can graph these two functions, linear function with the graphing calculator. Pretty simple equations. You see, like the first one, I can say 3x minus 2, 3x minus 2, say graph. You see, it's a good straight line. and A positive, so that means the graph is rising or increasing. If you go to the second line and then type G negative 2x plus 5 as an example, then you get this one. And A is, you see, A is negative 2 less than 0, B is 5. So it's false. Then in next example, we have several specific parent functions. The first one is called the identity function. Identity function is a special case of a linear function. You see, if this is a linear function, we have linear function ax plus b. If I choose a to be 1 and b to be 0, put them there, then you get f of x equal to x, which is a linear function, is a specific linear function, but it's a special one, so we call it an identity function, because whatever x is, the same get y. Like if I put f of 1 is 1, f of 2 is 2, f of 3 is 3, f of whatever x is, you get the same value for y. So y is equal to x, you see. So if you graph that on your graphing calculator, just put x there, you see, you get a graph of the identity function. The next one is called, well, of course, let's look at certain properties of this identity function. The domain is the whole real line, minus infinity to infinity. Range is minus infinity to infinity. X-intercept and y-intercept are both 0. No local minimum, no local maximum, and it's always increasing. So increasing over the whole real line. It's never decreasing. The second function is called the squaring function. Squaring function is f of x equal to x squared, and this is a special case of quadratic functions that we're going to study on the next chapter, first section of next chapter. But this is a very simple one, so we discuss it here. I can graph it in my graphing calculator. See, you get this graph, just like that. It's even. This one is odd. This one is odd. This one is even. The domain is the whole real line. Range, see, it doesn't go any below, so you go from minimum, which is 0 to infinity. The range is from 0 to infinity. X-intercept and y-intercepts are both 0. We have a local minimum of 0, 0 right here, no local maximum. Increasing on the right side, you see, it's going up this way between 0 and infinity, and decreasing on the left side and minus infinity to 0. Okay, so these are the properties of this one. The next specific function called cubing function. Cubing function means whatever x is, you cube it. F of x equals to x cubed. This is the graph. Of course, it's an odd function. That's the graph of it, so I can verify the graph on right here, x to power 3. You see, that's the graph of this function. It's an odd function. Domain is the whole real line. Range is also from minus infinity to infinity. X-intercept is 0, y-intercept 0, no local maximum, none, no local minimum, none. Increasing, always increasing, you see. Just keeps going up, you see. So increasing over the whole real line. And it's not decreasing at all. The next example or function is called squaring function, square root function. square root of x. And of course this function is odd as well. Odd, I should have circled that here. Let me see, the previous one I didn't have. Oh, it did. Forgot to. Here is even, you see. This one is even. The first one is odd. Okay. Odd, even. And this one is odd. And this one is neither. It's not odd, it's not even, it is whatever it is, it's neither one of those two. As I said before, a function doesn't have to be even or odd, it could be not neither one of them. The graph looks like this. You can verify the graph on your graphing calculator. Second square root of x, you see. Looks like that. Domain, as you see, there is no negative x value employed here. So the only x values used are 0 or bigger than 0. So domain is 0 to infinity. And for y value, you see, go from minimum goes up. So this is the domain, and this is the range. X-intercept is 0, y-intercept is 0. And local minimum 0, 0. Local maximum none. This is local minimum. It's the lowest point, and it's always increasing. You see. Increasing on its domain, increasing on 0 to infinity, never decreasing. The next function called the cube root function, cube root of x. This is the graph of it. You can verify the graph on your graphing calculator. Math, you see, number 4, cube root of x. If I say graph, looks just like the one I have. Of course, my window is a little bit different. That's why maybe it's a little bit flatter than the one I have. But basically the same thing. It's odd. Domain is the whole real line. Range is the whole real line. X-intercept 0, y-intercept 0. Local maximum none, local minimum none. Increasing all the time, you see. And over its interval, over this whole thing is increasing. Over minus infinity, so never decreasing. Absolute value function. Absolute value function means that whatever you choose for x, the y value would be absolute value of that. And absolute value, when you take absolute value, it makes the number always to be positive. Okay. So the graph of it looks like a V shape. So if you verify that, go to y equal to, erase that, and then to get the absolute value you have to go to math. You see math right here, and then go to numbers in UM, and then the first item is ABS. Choose that, the absolute value of x. You see, if I say graph, then you get this V shape. So the graph is that. And domain, of course, you see, any value for x is acceptable here. The domain is minus infinity to infinity. Range, you see, you never get negative values. So range is from 0 to infinity. X-intercept is 0, y-intercept is 0, local minimum is 0, 0. You see, this point is the lowest point. No local maximum. Increasing, you see on the right side, on this side, see, it's increasing. So increasing on 0 to infinity and decreasing on the left side, you see, on minus infinity to 0. Okay, the next example, or continuing the example one, the last item of the last example is called a reciprocal function. Reciprocal function means that whatever the value of x is, the y value would be y 1 over that. Like if x is 2, then y is 1 over 2. If x is 5, y is 1 over 5. Whatever x is, then y is 1 over that. Okay. And this the graph has two pieces because this function is not defined at 0. So at 0, things split. On the left side, you get one piece of the graph. On the right side, you get another piece of the graph. So if you graph it on your graphing calculator to verify this, to see what happens, you go to y equal to, clear that up, 1 divided by x. You see like that. If you graph this, yeah, it's not as clear as the one on the paper because your window is too big. So maybe if I change from minus 3 to 3, and this one also from minus 3 to 3, then it looks a little bit bigger. So you see, it's a familiar form like this one that you have on your paper. And of course, it is odd. Did I say that this last one? Oh, I guess I forgot the last one. The last one is absolute value function is even. You see, this is even because it's symmetric with respect to y-axis. This is odd. And domain is everything except 0. You see, 0 is not in the domain because not defined at x equal to 0. So that means 0 is not in the domain. So the domain is going to be everything from minus infinity all the way to 0, then from 0 to infinity. So there is a hole right there. So the domain is therefore minus infinity to 0 union 0 to infinity. Range is the same thing. You see, the y value goes from minus infinity to y-axis. You never touch y-axis, so it's never 0 like that. And then you start from 0, excluding 0, and then go all the way to infinity. See? Union 0 to infinity. X-intercept, there is no x-intercept. See, that never touches x-axis, none. Y-intercept, none either. So no x-intercept, no y-intercept for this function. No local maximum, no local minimum. It's always decreasing. You see, going down and then start back up here, and then start going back down again. So it's never increasing. Decreasing on its interval, decreasing on minus infinity to 0 union 0 to infinity. So a function, if it's increasing or decreasing, it happens always on its domain, okay, regardless of what the domain is. Another type of function that we discussed last time was piecewise functions, but I did not show you how to graph them. We said piecewise functions are those functions which are defined by two different formulas or recipe according to what the x value is. Like, for this one, if x is less than 1, negative 1, then you have to use this formula. If x is bigger than 1, you have to use this formula. So we know that. For example, let me just write a couple examples. If you say, if you ask what is f of minus 2, then you say, okay, minus 2 is less than minus 1, therefore I use this formula. It's going to be minus 2 squared minus 1, you get 4, minus 1, you get 3. However, if somebody asks you what is f of 4, 4 clearly is bigger than negative 1, then you have to put it in this formula. So you get 2 times 4 plus 1, you get 9, and whatever else value. So you always have to pay attention to your x value to see which one of these two conditions the x value satisfies, and then according to that, then you can decide which one of these formulas to use. Don't use both of them. If you use both, as I said before, you get two different y values for the same x values, and that would be the violation of function. Now, if you want to do this with a graphing calculator, then you get a function that has two pieces. One graph for this x squared minus 1. This is x equal to minus 1. If I draw a vertical line at x equal to minus 1, this is x equal to minus 1. You see, this minus 1. Then you have to the right of x minus 1 and to the right of x minus 1. If for the first equation, it tells you what you have on the left side. On the left side, you get one graph, and on the right side, you get another graph. Okay. So the easiest way to do this, we do it with the graphing calculator. So what I would do, I write it like this. I go to my menu, I'm going to type it in just a second. So you say y1 on your graphing calculator. Then you say parentheses. Then you type this first function, x squared minus 1. And then you immediately open another parenthesis and you put the condition x less than or equal to minus 1, like that. So let's do it as I speak. Unfortunately, you can't see this. Let me write it down first, and then, well, maybe make it bigger. Let's see. Yeah, this is good, right there. First, I'm going to type that. So I say parentheses x to power 2 minus 1. You see? Then parentheses x. I want to say less than or equal. Where do you get less than or equal? To get less than or equal, you have to go to here, test. You see, it says test. Right here, test. Above math. Test, T-E-S-T. So you have to say second test, second math. So if I say second math, you see, I have all these symbols I can choose from, and I needed less than or equal to. Less than or equal to is number 6. So less than or equal to minus 1. So I type this whole thing here. Now continuing. Then, so I did the first one, then you say plus, and do the same thing for the second one. Parentheses, 2x plus 1, parentheses, x bigger than minus 1, and that's it. That's all you have to do. If you have another one, then you do another one. But, so if I continue this here, plus, parentheses 2x plus 1 parentheses x bigger than negative 1. Bigger than negative 1, again you have to go to second math. Go to second math, you get all these symbols here, you see, and to bigger than, just strict bigger than is number 3. Bigger than negative 1. So I typed all of this. I typed all of that. Then all you have to do, just look at your window. I think my window is okay, so I'm going to change it to maybe minus 5 to 5, make it a little bit bigger, and this one also minus 5 to 5. And then all you have to do now is just say graph, and if you say graph, you see you get two pieces. One piece to the left side, this is -1 right there, this is right here. So you get one graph on the left side. If I do it on my paper, you see, you get one graph like this on the left, and then starting at right here, you get another line like that, you see. Of course you have to see, goes through point 1 there, that's what I went through, you see, like here. So this is a graph, two pieces, and these two pieces are not connected. So we say this function is discontinuous at x equal to -1. You see, so I say this function is discontinuous at x equal to -1. Because as you can see, at x equal to -1, which is right here, this is -1. At -1, you have one piece to the left, one piece to the right, and they are not attached to one another. In some situation they may be, then we say it's continuous. But in this particular case, this function is discontinuous. Okay? So this is how you do piecewise function on your graphing calculator. So let's try this again for the next one. See how this one, the next one look like. So what I have to do is to type it. So I say y1 equal to, again, parentheses 2x minus 1 for the first one, then parentheses x less than 0. So I did the first one, and then say plus parentheses negative 3x plus 5 x bigger than or equal to 0, like that. Okay. So in this case, the connecting point is 0 right here. You see. So you have one piece of graph to the left, one piece of graph to the right. I have no idea how it's going to look like until I graph it. Then we can tell whether it's continuous or not. Okay. So let's go to y equal to. So I'm going to save something. So 2x. So 2x minus 1 just erase the whole thing. 2x minus 1 parentheses x second math less than is number 5 0. So I did this part, and then I say plus parentheses again negative 3 x plus 5 close parentheses open parentheses x bigger than or equal to 0. Bigger than or equal to 0, go to second math. Bigger than or equal to 0 is number 4. There we go. So I'm done with this one too. So I typed the whole thing. Then if you like your window, just go ahead and say graph. This is one piece and another piece. See? This is also discontinuous. Maybe I should change my window a little bit because I cannot see the top of it. So I go, I guess minus 5 to 5 is good enough for x, but here I go from minus 8 to 8 to see more of it. You see, on the left side we have a line that comes to -1, and then the other one starts at some point at 0.5 and just goes down. So if I want to transfer this graph on my graphing my graph paper, so at 1, see at -1, you go something like this, and then at 5, 1, 2, I choose this one, 1, 2, 1, 2, 3, 4, 5. So this is 5. 1, 2, 3, 4, 5. So it goes like that. You see? That's good enough. Okay, I'm gonna quit right here on this section. The next one, I'm really not gonna do it. Okay, so it's not something that is required for the course. So I'm gonna just skip over this page. So that concludes this section as well. See the video as many times as you can to make sure you got all the ideas. And remember, there is no homework on this section. This section simply was for the purpose of learning about certain basic functions, and in particular, learn how to graph piecewise functions like these two. Because on the homework and on your test, you're going to see questions like this. Okay, so good luck.